We need to upgrade our geography books. Zealandia, the 8th continent. Could an entire continent be hiding beneath the waves, waiting to rewrite everything we thought we knew about the Earth's fundamental geography? Imagine discovering an entirely new continent hiding in plain sight. Not in some distant galaxy or alternate dimension, but right here on Earth. Zealandia, a massive landmass the size of India that's been beneath our noses, or more accurately, beneath our oceans the entire time. For centuries, we've been taught that there are 7 continents on Earth: Africa, Antarctica, Asia, Australia, Europe, North America, and South America. But what if everything we thought we knew about our planet's geography needs to be rewritten? Be sure to keep watching until the end of this video, because I'm going to reveal the shocking scientific evidence that finally convinced geologists to recognize this hidden continent after decades of skepticism. So don't click away. You won't want to miss these groundbreaking discoveries that completely transform our understanding of Earth's fundamental structure. The story of Zealandia's recognition is one of scientific persistence and revolutionary thinking. In 1995, geophysicist Bruce Leuendijk first coined the term Zealandia to describe the massive submerged landmass in the southwest Pacific Ocean. But it would take more than 2 decades before the scientific community would seriously consider this radical proposal. Why? Because Zealandia challenges everything we thought we knew about what makes a continent a continent. Traditionally, we've defined continents by the land we can see above water. It's a surprisingly simplistic definition when you think about it. If continental status were determined by visibility alone, wouldn't that mean continents could appear and disappear with changing sea levels? The reality is that our planet's fundamental structures extend far beyond what we can see with our naked eyes. The pivotal moment came in 2017 when a team of geologists published a groundbreaking paper in GSA Today entitled Zealandia, Earth's Hidden Continent. This wasn't just any scientific publication, it was a direct challenge to centuries of geographical convention. The authors presented compelling evidence that Zealandia satisfies all the requirements needed to be classified as a continent. It has a distinctive geology, a well-defined area, and elevation above the surrounding area, and crucially, it has thicker crust than the ocean floor. What makes this discovery so revolutionary is Zealandia's unique characteristic. It's almost entirely submerged. While other continents have approximately 70% of their landmass above water, a staggering 94% of Zealandia lies beneath the ocean's surface. The visible portions? Just New Zealand, New Caledonia, and a handful of small islands that previously seemed disconnected. But these aren't just islands. They're the mountain peaks of an entire continent. Modern geological definitions have moved beyond simplistic visual criteria to focus on 3 key elements that define a continent: composition, made of continental rather than oceanic crust; size, generally at least 1 million square kilometers; and elevation, sitting higher than the surrounding oceanic floor. Zealandia checks all these boxes with an area of 4.9 million square kilometers, continental rock composition, and elevation above the surrounding seafloor. The discovery represents one of the most significant geographical revelations of our time. It's not often that we fundamentally revise our understanding of Earth's basic structure. Adding an 8th continent to world maps is comparable to discovering a new planet in our solar system. This isn't just an academic curiosity. It's a complete paradigm shift in how we understand our world. Zealandia's recognition journey also highlights the increasingly sophisticated tools available to geoscientists. What was once impossible to detect beneath kilometers of ocean is now visible through advanced technologies like satellite gravity measurements, seismic imaging, and bathymetric surveys. These tools have essentially given scientists X-ray vision to see through the ocean and reveal the continental structures hidden beneath. The most compelling evidence for Zealandia's continental status comes directly from its rock composition. While oceanic crust consists predominantly of dense, dark basaltic rocks, continental crust contains lighter granite and metamorphic rocks, exactly what scientists found when analyzing samples from Zealandia's underwater ridges. Rock cores extracted during research expeditions revealed continental granite, schist, and gneiss materials that simply don't form on the ocean floor. These rocks tell an unmistakable story. This isn't just an anomalous seafloor feature, but genuine continental crust. Perhaps more fascinating is what these rock samples reveal about Zealandia's ancient history. Dating techniques show that many of these continental rocks formed between 500 and 100 million years ago, directly linking Zealandia to Gondwana, the supercontinent that included Antarctica, Australia, Africa, South America, and India. The evidence suggests Zealandia was once firmly connected to Australia and Antarctica before breaking away approximately 85 million years ago. An astonishing continental divorce that reshaped our planet. The International Ocean Discovery Programme's 2017 expedition recovered sediment cores from Zealandia that contain pollen from land plants and spores from terrestrial fungi, clear evidence that much of this now submerged continent once stood above sea level. Some samples even contain remnants of trees that once grew on Zealandia's surface, suggesting a vibrant terrestrial ecosystem existed on this land before it slipped beneath the waves. Hey guys, before moving on, don't forget to subscribe to our channel if you haven't already. Make sure to hit that notification bell so you don't miss out on any of our weekly videos. Back to the video. The complete mapping of Zealandia in 2023 represented a monumental scientific achievement. It became the first continent to be completely mapped from its highest peaks to its deepest underwater boundaries. This wasn't accomplished through traditional surveying, but through sophisticated marine geophysical techniques, including multi-beam echo sounding, which uses sound waves to create detailed topographic maps of the seafloor. What these maps revealed was striking. Rather than a random collection of submarine plateaus, Zealandia displays the cohesive structure of a continent with defined boundaries where its continental crust meets the surrounding oceanic crust. Its northern boundary extends to the New Caledonia Trough. The eastern margin follows the Kermadec and Tonga Trenches. The western edge meets the Tasman Sea, and the southern limits approach Antarctica. The seismic profile studies provide another layer of evidence. By measuring how sound waves travel through different materials beneath the seafloor, scientists can determine the composition and thickness of the crust. These studies confirm that Zealandia's crust ranges from 10 to 30 kilometers thick, significantly thicker than typical continental crust, which averages 30 to 40 kilometers, but still much thicker than oceanic crust, typically only 7 kilometers. This unusual thickness explains why Zealandia sits lower than other continents. During its separation from Gondwana, powerful tectonic forces stretched and thinned Zealandia's crust like pizza dough, causing much of it to sink below sea level. This process, known as crustal extension, resulted in Zealandia's unique status as the world's first predominantly submerged continent. Gravity anomaly measurements from satellites provided the final piece of the puzzle. These measurements detect slight variation in Earth's gravitational field caused by mass differences in the crust below. Continental crust creates different gravitational signatures than oceanic crust, and when these measurements were compiled into maps, they clearly outlined Zealandia's 4.9 million square kilometer expanse as a distinct continental entity. The complete body of scientific evidence became so overwhelming that in 2017, geologists formally proposed reclassifying Zealandia as Earth's 8th continent. What makes this discovery so revolutionary isn't just adding another name to geography textbooks. It's fundamentally changing our understanding of what constitutes a continent and revealing that our planet's geography is far more complex than we previously understood. This discovery forces scientists to reconsider formation, evolution, and even how life might have spread across the planet. For geology students worldwide, this means learning about 8 continents instead of 7, a rare moment when established scientific knowledge undergoes such a significant revision. Zealandia's recognition has profound implications for evolutionary biology as well. New Zealand's unique flora and fauna, species found nowhere else on Earth, have long puzzled biologists. How did these species evolve in such isolation? The Zealandia model provides compelling answers. Rather than viewing New Zealand as islands that species somehow reached across vast oceans, we now understand it as the remnants of a much larger landmass that once supported extensive terrestrial ecosystems. This explains why New Zealand hosts unusual species like the flightless kiwi bird and ancient reptiles like the totara. They're not colonizers from elsewhere, but descendants of species that evolved on Zealandia before most of it submerged. The continental status of Zealandia also carries significant legal and territorial implications. Under the United Nations Convention on the Law of the Sea, countries can claim exclusive economic rights to resources on their continental shelves. New Zealand has already used the Zealandia research to support its submission for an extended continental shelf, potentially giving it rights to vast undersea resources. This precedent could inspire other nations to reassess their own continental boundaries and resource claims. The submerged nature of Zealandia offers unprecedented research opportunities. Unlike other continents that have been weathered by billions of years of exposure to the elements, much of Zealandia has been preserved underwater. This makes it a unique time capsule of Earth's geological and biological history. Sediment cores from the ocean floor have already revealed details about past climate patterns, ancient ecosystems, and even how the continent responded to the asteroid impact that ended the dinosaur era. Zealandia essentially provides a different kind of fossil record, one preserved by submergence rather than the traditional fossilization. Future exploration of Zealandia will likely yield discoveries we can barely imagine today. Advanced underwater vehicles and drilling technologies are making it possible to explore deeper and more precisely than ever before. Scientists are particularly interested in Zealandia's submerged plateaus and ridges, where ancient shorelines may preserve evidence of prehistoric life. There's even speculation that Zealandia's unique conditions might have preserved remnants of ecosystems that disappeared elsewhere on Earth millions of years ago. Perhaps most importantly, Zealandia challenges our perception of continents as permanent, unchanging features of our planet. This mostly submerged continent demonstrates how dynamic Earth truly is. Continents can stretch, thin, and sink beneath the waves. What we perceive as permanent is merely a snapshot in geological time. If Zealandia could transform from a terrestrial landmass into a submerged continent, what might happen to our familiar continents in the distant future? Could portions of today's continents eventually sink beneath the waves as new landmasses rise elsewhere? The story of Zealandia also highlights how much remains unknown about our own planet. If an entire continent could remain unrecognized until the 21st century, what other fundamental aspects of Earth might we still be overlooking? This humbling realization underscores the importance of continued exploration and research, even in areas we think we understand all too well. As technology advances, our understanding of Zealandia will undoubtedly grow richer. Planned research expeditions aim to gather more rock samples and map Zealandia's submerged landscapes in greater detail. Scientists are particularly eager to study how Zealandia's submergence affected global ocean currents and climate patterns, knowledge that could improve our understanding of today's changing climate. The recognition of Zealandia reminds us that scientific understanding is never complete. It evolves as new evidence emerges and new technologies enable us to see our world differently. Just as we believed Earth was flat, then the center of the universe, we once believed there were 7 continents. Now we know there are 8. And who knows what other fundamental revisions await our understanding of this remarkable planet we call home. Which other geographical mysteries would you like us to explore next? Drop your suggestions in the comments below and check out our next videos on the end screens, which should be up right now. See you soon.